Welcome to our Introduction to Acids and Bases. The study of acids and bases is a major topic in chemistry, and they also play a role in your daily lives. For example, acids can be commonly found in soda, vinegar, and citrus fruits, whereas bases can be commonly found in ammonia, which is in a lot of household cleaning products. Ammonia is a base. Bases are also part of antacids, and you also find them in soaps. These are some common examples of acids and bases, but there are also some general properties that we can use to try and recognize acids and bases when we see them. So let's start with acids. Acids typically have a sour taste, which becomes evident in things like vinegar. So there's acetic acid in vinegar that gives it its characteristic taste. There's also citric acid in some fruits, like lemons, for example. Bases, on the other hand, have a bitter taste. And while taste seems like it's a good way to distinguish between acids and bases, I strongly urge you to not taste either one of these in a lab. Another thing that's useful to know about acids and bases is that they're both electrolytes, which means that they conduct electricity when they're dissolved in water. And while they both have this property of conducting electricity when they dissolve in water, they do react differently with different substances. So acids react with metals to produce hydrogen gas, whereas bases can react with fats to produce soap. And we actually call this process saponification. And this is how soaps are made. Related to this idea is that bases also feel slippery, which is why soap feels slippery. And the last property that we'll use to identify acids and bases is something called pH. And you've probably heard of pH before, but acids have a pH of less than 7, whereas bases have a pH greater than 7. Another way of distinguishing between acids and bases is to use something called an indicator, which is just a chemical that changes color when in contact with an acid or a base. Let's look at a few more common acids and bases. On the left, we have some common acids that you may come across at some point. Nitric acid is an acid we sometimes use in lab. Sulfuric acid is also an acid you may run across in lab, but beyond that, it's found in car batteries. Hydrochloric acid is another very common acid we'll use in class, and is found in your stomach. And the last one is acetic acid, which is a weaker acid, but it's the acid found in vinegar. On the right side of this list, we have some common bases, and these bases frequently have common names, like sodium hydroxide, which is a very common one we use, is commonly called lye, and calcium hydroxide is commonly called lime or lime water. So the next question we're going to ask ourselves is what makes something an acid or a base? We know how to distinguish them now from their properties, but how do we know what actually makes something acid or what makes something a base? And the earliest explanation of what makes an acid and what makes a base was proposed by a Swedish chemist named Svante Arrhenius. And we call his definition the Arrhenius theory of acids and bases. So Arrhenius basically said that acids contain the hydrogen ion, and that they release it when they ionize. So if we look back at our list of common acids and bases, and we look through the acids, you're going to see that each of these acids has an H in it. Nitric acid, sulfuric acid, hydrochloric acid, acetic acid, they all have this H in them, the hydrogen, that can become a hydrogen ion. If we look at the bases now, ignore ammonia for right now, but you'll notice they all have this OH group. And that's connected to how Arrhenius defined bases. He said that bases contain the hydroxide ion, the OH ion, and that it gets released when the base is ionized. So let's take a look at what's meant by these statements. We'll use a fairly common acid, hydrochloric acid, and we'll have it in its gaseous form, hydrogen chloride. And if we put it in water, so we put it in water, it's going to dissociate, it's going to ionize. We know that because acids and bases are both electrolytes, so they dissolve in water. And when this dissolves in water, we're going to get the H plus ion, aqueous, and the Cl minus ion, also aqueous. So we would say that this compound, this was a covalent compound, it ionized. It became ions when dissolved in water. I can also show this with a base. If we take sodium hydroxide and we dissolve it in water, we're going to get the sodium ion and the hydroxide ion. So because it releases the hydroxide ion when ionized, that makes sodium hydroxide a base. just like HCl releasing the H plus ion when it ionizes makes it an acid, according to Arrhenius. Now the Arrhenius definitions are good in that they're the simplest and easiest to use, but they don't explain everything. For example, Arrhenius can't explain why ammonia is a base because it has no hydroxide ion, but ammonia is definitely a base. So to understand why something like ammonia is a base, in addition to these other ones, we need a more complete definition. And in the second part of this video, we're going to look at 2 more definitions of acids and bases that give us a more complete understanding of them.